Hello. Good evening. Boom.
Hi.
Yeah. Thank you for asking. I had enough food.
What?
不是问了要问吃饱了没吗？
没有 I just said hi.
Yeah, I was kidding. I know you said hi. 在马来那个华人打招呼有没有这个说法？是先要说吃饱了没？
新加坡有啊。
哦，说的是什么话？
福建吧。
哦，你家爸爸是吧？
对，诶，你也会？
我过去在厦门念书念了8年，但是我努力与福建话抗争，所以一点都没学。
啊，
宿舍里面其他人都说的是福建话，但我坚持说普通话。
那有点像我。
你家乡话是什么话呀？普通话？
福建啊。
教国语是吧？家乡话是
福建啊。
你会讲吗？
我父亲是福建人呢。不会啊，只会听。
但是你的那个国语从哪学的？
国语学校家里啊。
老师会教啊，就是像这样讲课。
老师什么？
老师会教吗？普通话
会啊，我们有中文课啊。
Hi, Tor. You have a nice picture. How do you get that? Oh, your side.
It's just the background. I think maybe it's time to change it. It's not really the season anymore.
Oh, so this is software you use, right? Replace the wall with this.
Yeah, Zoom supports it to just put in a background image.
Oh, then I found a really good practical joke. Next time I will do the Zoom meeting next to a stable, and then you will see background with horses, and then when one of the horses actually get himself between the screen and me, everybody will say, "Wow, it's not really a background."
You can actually also use a video as a background. So I've seen someone basically using the Rickroll video as a background.
Hello, James.
Hi. Nice background. No, it's gone. I just saw it.
Thanks.
Oh,
it's a picture I took in Switzerland in January.
Nice. Okay, so I hope I prepared this discussion a little bit more, but today has been a busy day. I literally couldn't squeeze in a few minutes to prepare test cases for what I wanted to talk about today. So we are going to do a lot of theoretical talk. There are 3 occasions that I found that current signing algorithm is not sufficient. So current signing capacity provided by our wallet is not sufficient. The 3 scenarios are: first, you cannot really generate session key with the key stored in. You cannot apply Diffie-Hellman with the key kept in our wallet. And second being, you cannot sign anything other than using KeyCache, which wasn't the problem until very recently, which I will explain. And third is that Paul has mentioned that we can use Schnorr zero knowledge proof of knowledge of a discrete log, right?
Yeah.
And you have a way to convert that into a non-interactive protocol. And I believe I only read the interactive protocol. I didn't read how you turn it into non-interactive. But the interactive version will use something that simply signing will not solve.
Okay.
Yeah. So we will need to use the key in a more free way, I guess. So
Can I have your drive license for the parcel?
关门，关门，关门。This is exactly what I mean. No matter how many times I say that you can't enter my room, and there are always excuses to just get in. There's no way I can solve this. So the second scenario I just hit recently, where our wallet is not able to sign anything other than 256 KPEG. You cannot hash the signed message with SHA-256, for example. And I hate this problem because I'm trying to get a PHP-based engine to use to do a login authentication. And PHP is able to send a challenge, but we are not able to send back the challenge signed because the PHP side uses OpenSSL as its crypto library, and OpenSSL doesn't provide KCAG. It cannot validate signature that is hashed by KCAG. And even worse, OpenSSL doesn't allow you to provide your own hash function. So even if you could write a KCAG implementation in PHP, it wouldn't help. That's because OpenSSL explicitly did this to prevent developers to roll out their own crypto, which is exactly what Vitalik did. So that's causing a conundrum. So I believe that in order for zero knowledge proof of the Schnorr protocol, how do you call it? You just call it Schnorr protocol? The one, I just use the word Schnorr protocol. Yeah, we need to expose more than just signed Ethereum message interface to the DApp, as well as to TokenScript, but maybe first to the DApp because it's always easier. So I talked about this with Boon early in the morning yesterday to check how does at which moment Web3.js passes the signing task to the Alpha wallet, which is a browser, right? And I wanted to find out exactly line of code so that we can discuss around it, but I didn't get around to do that. So Boon, is it easy to have a look at exactly where the signing is passed to the user agent?
Yes, give me a minute. Oh, hang on. Pass to the user agent.
Yeah, I will use the word user agent in the future because it's not clear when we say native app, but sometimes we mean browser because browser is also. So when you sign something, the signing must happen not in the JavaScript memory because otherwise you might leak the key. So it has to be done by the user agent. Be the user agent. The user agent can be the wallet. It can be MetaMask. It can be the browser itself, but it cannot be inside the web page with JavaScript. So all of these three, that is MetaMask, a special browser, or Alpha Wallet, all these are user agents. I just call them user agents to distinguish them from the JavaScript memory space. Can I just use this terminology?
Yes.
Okay, so we agree on that. So is it easy to show us how this is done? How the JavaScript starts to ask the user agent to sign stuff?
Sure, yes. Let me try to send a link.
Sorry about asking this suddenly because I wanted to find it myself, but today has been a crazy day.
I pasted a link in the chat.
Nice. And is this very similar on Google's Android side, James Brown?
The part which I pasted, yes.
Okay, basically it's WebKit, message handler, sign message, and I believe everything after message handler is specific to the user agent, right?
Yes, to WebKit.
So it means
So
that
this line.
So if I run this line in Safari, then it will say sign message doesn't exist. Right?
Oh no, actually, that's what I wanted to check. This chunk of code, starting from line 97 to 102, is 6 lines of code. Inject a function called sign message, a JavaScript sign message into the browser, into the user agent. So the dev developer can call this sign message function, which will result in line 102 being called.
Is Swift code.
Yes, this is line 102 will trigger Swift code. Line 102 is JavaScript.
I don't understand. How can JavaScript install something into the user agent?
No, this is the native code side which installs the JavaScript into the user agent.
Which means what I'm reading now is Swift code. Yes, of course it is, because it's not Swift file.
It is, but the section you're reading is actually a string which is injected into the user agent.
I see. So it starts from the const part.
Yes, yes. So if you look at line 97 to line 102, this is one of the functions, JavaScript functions, which we inject into the user agent.
Nice. And
so when the dev developer calls the JavaScript function sign message, when they want to sign a message, it will end up with line 102, still JavaScript being run. This line 102 is special, it's provided by WebKit, the user agent, to bridge into the native code.
So how does it look like if you call from native side?
The native side doesn't call this.
Sorry.
The native side is being called by this.
How does the JavaScript running in browser look like, on the website look like?
Okay. Let me try to find an example.
The other side of it. Thank you. And James Brown is similar
yes.
to.
Yes, that's right. Yes, so in Android, everything goes through Bouncy Castle. So basically, using the ECDSA soft code in Bouncy Castle, in the Bouncy Castle library, ECDSA signature. Hang on, yeah, EC key pair. Yep. So it's all pretty standard. Hang on just a minute. Let me just see, generate signature.
So yeah. Tor, the reason we are looking at this is we want to find out if we want to add additional capacity, for example, to generate zero knowledge proof in Schnorr protocol. What kind of API do we need?
I mean, basically, it's like based on standard discrete log operations. So in this case, it would probably like standard curve operation, like point addition and point multiplication.
Cool.
Yeah. There's nothing like too fancy going on. It's just general and the hash function, of course. But it's pretty.
So basically, it's the same as if you how do you get a public key from a private key, because that is also a elliptic curve operation.
Yeah, it's along the same line.
Yeah, I see.
Okay. Sorry, Tor. Which algorithm did you say that the Schnorr uses?
It doesn't really use any algorithm. It's just based on discrete log groups. I mean, so you can use it with elliptic curves as well.
Okay. Okay.
So as long as you're in any mathematical group, that supports the standard group operations, you can use it. And also assuming you have a hash function.
Yes. So basically, we're just using Bouncy Castle in Android, which I presume would, where it would do all that kind of stuff.
So sorry, Victor Boon, do you have anything?
Yes, I pasted a second link into the chat.
Thank you very much. Let me open this.
Line 32.
32. Yes, but this is this looks like the API provided by web3.personal, and what is inside it?
Yes, what is inside is actually provided by us in the previous link in line 97 to line 102. It's not exactly the same function, but they are almost the same. So
No,
pretend that sign is sign message. So
Oh,
if you look at the second link,
Example,
line 72,
yeah,
the dot sign, pretend is dot sign message. So sign actually calls line 97 in the first link. The function is not provided by Web3.js. It's actually provided by us, the user agent, the wallet provider.
So this is the callback to the code inside the app, though, isn't it?
The hooks.
Yes, the hooks for the call to the
callbacks
app.
that we install.
Yeah.
Which means the string that has JavaScript, it actually starts from function, not from const.
There's more than one function being injected. Line 97 is just one of them.
Yes, I noticed there are multiple, but each of them is the column there. After that, it's the string that contains the function that is in JavaScript. But before the column, it is Swift, right?
No, it is JavaScript. It's a dictionary.
Oh, so the whole thing is so it's starting from line 690. All of the line below are JavaScript.
No, actually, starting from line 79, right after the colon, right after the double quote, that's JavaScript. Space is needed here.
I couldn't see double quote on line 96, 97.
79.
Ah, I see. So the whole thing is injected there.
Yes.
So the sign function, I see. So the sign message is a function defined here that calls message handler dot sign message. So yeah, I see. So this will be these lines you are showing me is going to be in the memory of JavaScript.
Yes, and
Okay.
line 102 message handler is a special function provided by the user agent to hook into native code.
Yes, and the native code has to have sign message function defined somewhere, not in this page.
Right.
I see. Okay, so now I understood how this mechanism works. Thanks a lot. Yes, this morning I wanted to start look at window.crypto object because I think that's the ECMA standard on how the user agent should expose the signing function and other crypto functions to the JavaScript. The reason there is a ECMA standard on this is that you can, if the browser or user agent provides signing function, then it's apparently the key is not stored in the memory of JavaScript, and it has to be secured somewhere, and you cannot allow JavaScript to do any manipulation on that because you will probably exploit memory and getting knowledge from JavaScript. So it has to have a standardized interface to do that. And actually, when Vitalik wrote out Web3 and says that it can run in the browser, I thought they would follow and add new functions into a window.crypto interface. But apparently they didn't and started a new thing called Web3 something because they think they are the new web, therefore they should not use anything that is part of the old web, I guess. So I'm just looking at whether or not it makes sense for us to use the interface to expose more functions to TokenScript and to website as well. Can I share my screen now? Let me see if I can share it. Yeah. So not many people are using these APIs. That's why I'm not familiar with these APIs. So this is the Mozilla document. This API exists on everything in Safari, Internet Explorer, and everything except crypto browsers. This crypto interface exists in everything except today's crypto browsers. So it seems that they have put under the crypto object, which is what all the interface will be, crypto-related interface will be. There is only one element called Sato, and I don't know if this is the decision by. I think it's not a decision by Amazon. I think this is part of the standard, because Sato is related to key management, while other things like crypto.getRandomValues, these are used without key. Sato simply is their way of calling something that relates to the private key, I believe. You remember that back in the bank, I called the project DMZ only to make people aware that there's no key in it. Like, why do I do that? Why don't they call it keyless? The reason is that DMZ makes people who are not familiar with crypto think, it's safe to do certain things here without worrying about keys. So I guess they use the word Sato here because they want people to think, if I don't know what it's doing, I should not do it. I think that's how the word come to be. Then if you go into the Sato, it provides typical stuff like, it provides typical stuff like encrypt, decrypt, sign, verify, and digest. These typical functions, sorry. Yeah, and I haven't looked at the exact parameters allowed in these ones. I know one thing for sure, that they don't support KCAC, because that, as I looked up, this is the main reason Web3 people decide to use their own crypto library. That they don't have they couldn't agree on the crypto details. I was wondering that if we add something, so that let's say here is a clear one, derived key. So so if it does what I think it does, then this function derived key is sufficient to support zero-knowledge proof Schnorr protocol. Make sense? I just need to check what it is really in it. Yeah, can be used to derive a secret key from a master key. So to my understanding, and this is just my understanding, that the derivation of a secret key from a master key is the same operation that derives a public key from a private key, starting from generation point. Simply that in this case, the master key is public key is the generation point.
Okay. Not being familiar with this API at all. I mean, when I hear a crypto.derived key, I think more of a key derivation.
Tell me again.
Function. I'm just trying to figure out what exactly is, because I mean, normally when I think of a method called derived key, I would think of one that that's basically a key derivation function.
Mm-hmm.
So basically like an user-rated HMAC function, but
so yes, when you have HMAC, and once you have that, you would use that as to do, let's say, elliptic curve, right? Then you would use the value of this HMAC to do an elliptic curve multiplication.
Yeah, I mean, sure. It's basically, you know, just a nice random a nice hash function. I mean, you still need to map that to a point on the curve. So in relation to this, I have so it's actually standardized. how to do the Snow protocol based on elliptic curves. There's apparently like a bunch of standards. So I just posted a link to a discussion on Stack Exchange about that. Yeah.
Okay, let's look at the syntax. This one has algorithm. I think this is a algorithm indicator. It doesn't have any key related variables. And base key, and derivation key algorithm, and extractable. No, it says ECDH.
There are more details below parameters.
Crypto, Tor, I'm thinking about this. If you imagine the user agent supports the curve, which is SECP 2056K1, and you observe the parameter that is defined here. If the user agent actually supports the right curve, would you be able to use this to do what is needed in the Schnorr protocol? Or is this not
it's a bit hard to say. I mean, there's there's the deviation I see to the ECDH. So like the deviation to a ECDH private key, which is like a point on a random point on the curve, which would be the nice start of that. Like if you look at the link, that's basically point 1 and 2, like pick a random value and then multiply this to the generator of the curve, and take the x point. So I mean, basically what happens at least in this case, it seems that you basically get a random. You take the generator of the curve and then you pick a random value and you multiply it and then you return this random value.
So it's random, and what we need is to pick up a point and then to derive a key with a given factor, derivation factor, not a random number.
Yeah, but as far as I understand what they mean when they see the ECDH private key, it's like it's exactly that. Like if you remember what if you remember with the the Diffie-Hellman, it's basically just you pick like if you consider normal groups, you pick a generator and you pick a random exponent, and the random exponent would then be the private key. And like the generator lifted to the exponent would be the public key. So in like the curve setting, that's like you take a generator point and you pick a random value and you multiply the generator point with that random value.
Okay, this is how I remembered the ECDH. I will explain to you so you can correct me. I should have prepared better next time. Let's say Alice and Bob. So each will first generate their private key, which is a randomly selected number for them.
Yeah.
And each will go from the generation point to do and using that number as exponent and get a public key, which is another point. And then each party will use the other party's public key, which is a point, to generate a new point using their private key as the exponent. And that new point will be the ECDH key, right?
Yeah.
Okay. So basically, this operation would allow the user to choose a base key, I believe, which is the new generation point. Sorry, the public key of the other party. Because it sounds like because if you think about the second stage, where Alice and Bob will generate a new point based on each other's based on the other person's public key and their private exponent, then this is a process similar to getting a public key for private key by knowing the private key, getting a public key, except that instead of generation point, you use the other person's public key.
Yes, yes, that's correct. Yeah.
Yeah. So if this derived key algorithm does what I think it does, you can provide the other person's public key in base key, and then you can provide yourself, and then there's a hidden, not in the parameter. There's a private key hidden, not in the parameter, because you cannot supply private key in parameter. That's the whole point of designing this API. The key that is not a parameter of this function, which is the user private key, will be used to derive a public key using the base key as a generation point.
Yeah.
I think this is what it does. And if this is what it does, then it sounds like we should be able to use this to do Schnorr protocol, because I noticed the Schnorr protocol, the operation that's repeatedly been used is to use a different exponent at different point and generate another point. But no, actually, no, we cannot do this, because in Schnorr protocol, it's needed that you are able to generate a new point from a number you received from a verifier. And this API doesn't provide you the function of receiving such a number because it's using the private key. Let me check Schnorr protocol. Can you open this link so that I can stop sharing, and then I can start to check the protocol?
Yeah. So basically, the link. So the link I sent doesn't have the last step, which is actually the verification. It just has construction of the proof. So that was what I was talking about, which we can. It seems that we can use this method to at least do that, because basically, we just, because that, like the ECDH is basically, map to a random, like do a random point multiplication in an elliptic curve, and so
okay.
Verification, we still need to do the same, but we also need a point addition.
Yeah, we don't have point addition. That's right. We don't have it.
At least not there. Yeah. So again, this is this page doesn't. This only. Like, okay, so basically this specific question is just about the fact that there are two standards for doing a Schnorr proof based on elliptic curves, and it's just like a bit of a discussion of that. So it doesn't actually include the verification, at least there. But I mean the verification is taking.
The verification can be outside. We have to produce the proof first. Actually, do we need verification in our protocol, Alice to Bob protocol? Because if Alice and Bob doesn't need to verify, only smart contract needs, then we don't need to solve it in JavaScript. I don't remember what other protocol requires. Where's the protocol? You have the where is it? TokenScript. No, yeah. Blockchain attestation.
Yeah. Oh wait, no, sorry. That's the discussion. Sorry, post the link to the discussion instead.
Okay, this is the protocol, and then you have to amend it in your mind because this one doesn't use neural knowledge proof.
Yeah.
It's
not. I mean, we don't necessarily. Yeah, I don't know. There shouldn't be any. I mean, like basically, the suggestion itself is just like about having the smart contract verify the proof.
Okay. Good.
And I don't think there's any need to also. No.
Good. So there's no need to go through the web verification from the JavaScript side.
Yeah. No. Yeah. Yeah. That's correct. Yeah.
And let's look at the protocol. I don't know how to read this protocol. It's not written in similar format as
It's basically it's because it's written it's written in elliptical format. So like I mean, first step is pretty clear. You pick a random number, so that's pretty that's straightforward. So as far as I can read, like so basically the second is you take some point on the curve, like the generator point, and you multiply with this random number. So
yeah.
This is equivalent to taking a generator in a group and lifting to the exponent k.
Oh, wait a moment.
And then
just for a moment. The reason we are looking at the Schnorr signing is because the zero-knowledge proof one is similar to the signing of an empty message, right?
Yeah, it's based on that. Like I mean, no one actually uses Schnorr signing. But you actually end up just using the protocol for zero-knowledge proof.
Okay. Sorry. Go back to your one. So we have a hash of message and QX, and in this case, message is empty, right?
Yes, it is.
I think a friend of mine once sent me the Schnorr protocol using zero-knowledge proof without the signing bit, which might be easier to read.
Yeah, it is.
Let me see if I can find it.
Yeah, let me send you a link to it. Of course, now it's just because this description is in like normal group format.
Okay, so this is from
it didn't. If you click on the link, then it goes. This is very general, the one you're looking at. If you click on the link, it should take you to the point of a Wikipedia page where it's like just a Schnorr.
So yeah. So I just opened this one.
Yeah.
Actually, I just opened it. So sharing Schnorr protocol, right?
Yeah.
So.
But then again, of course, this one doesn't generalize the Fiat-Samir approach. But basically, like the thing is basically with the Fiat-Samir, instead of having the verifier pick a random challenge, you instead define the challenge to be the hash value of t.
This protocol, is this interactive protocol? It looked very simple.
So this one is the interactive because it says in step 2 the verifier picks a challenge and replies with that. So when you use so this one is interactive. So the way it becomes non-interactive is instead of having the verifier pick a challenge, you basically just set the challenge to be the hash of t.
Sorry, this one is interactive or non-interactive?
The one there is interactive because the verifier picks a challenge. So instead of picking the challenge, it's just gonna be the hash of it's just going to be the hash of T and any other parameters basically for this.
Okay, so this is one round in the interactive protocol that I'm highlighting.
Yeah, I mean, it's the only round. It's all that happens. This is the entire protocol.
Oh, I see. The prover sends the third message response.
Yeah, and so instead of hold on, maybe it's just easier to write it out because it's pretty. it's not the last thing.
Anyway, I don't think this this look like we need some addition, and the key derivation part is not enough to me.
Yeah. That's correct. In any case, you would then, but doesn't the library? Like, there's no. I mean, you need a multiplication and an addition or subtraction modulo the group order, basically.
So what I want to find out is one of these APIs implementable to us, or do we need to invent new ones? Yep, this one allows us to choose the signing, the hash mechanism. So okay, yes. So at least we know if we implement this API, we can provide we can solve the problem that OpenSSL using library is not able to verify the signature. Then there's one problem left, and we also know this can generate a Diffie-Hellman key. So the only one problem left is whether or not this set of API is enough to do the Schnorr protocol, or should we implement a new function, a new API, in addition to these?
Yeah, so it seems that like what remains the issue, as you also mentioned, is the computation. It's like the especially is the multiplication and addition. Because what happens? So what happens? Like when it's over a curve is that you end up having to take to basically like use the number that's derived from the x point of the curve, and then do a multiplication and a subtraction modulo the curve order.
I feel we cannot solve it now. Can I leave this as a task to you, Tor? That that is to define API with following in mind. First, this API needs to support the protocol that you just amended, and second, this API is an API called by JavaScript, and apparently you need to assume that the private key is not leaked by, suppose the JavaScript is written by a not trusted party. No matter how the JavaScript user calls the API, the private key used for zero knowledge proof is not leaked. And then the API will be handled by the user agent, which runs in a different memory space than JavaScript.
When you say the private key, do you mean Do you mean the random challenge in the proof, or do you actually mean the value we want to prove knowledge of?
The privacy key in our protocol, which is used to where you use the zero knowledge proof on.
Yeah. Okay. Yeah. Yeah.
So we need an API that is called from JavaScript by untrusted JavaScript code to provide zero knowledge proof of knowledge of the key. And the caller must not be able to find out the key.
Okay, well, that seems that seems quite hard because okay. So you mean the key must be so the API must basically work on the encrypted key, basically, because necessarily you need to.
I mean the following, that at no circumstance the key that is the subject of zero knowledge proof of the key, right? So we call it the secret key. Let's call it secret key. In no occasion the secret key will be passed to or from the API. So simply, this is a conversation between JavaScript in the browser and user agent. The user agent has the key, and the JavaScript in the browser asks it to make a zero knowledge proof. So the part of the design of the API is you need to bear in mind that none of these APIs has a private key in it. If you look at this sign, there's no private key in it's algorithm.
So basically, it's something like instead of actually inputting the private key, the user randomizes the private key and do a zero knowledge proof on that, and then basically give the random whatever it randomized it with to the verifier as well.
Yeah. So actually, they do pass a key object.
Yeah, that makes sense.
The key object is not the key. The key object is simply you cannot the JavaScript cannot read this crypto key object and find out what is the key in it.
Yeah, but I think like the issue is like if we talk about like the API as the one you showed, is that what's the key there is actually not what we want to protect. I mean, we want to protect the value that the user needs to show that it knows, since that's the value. Since knowledge of that value is what's needed to open the check. And like for the Mozilla for the API you showed before, basically the ECDH private key is not this value. This is just some random value used for this challenge. It's just used for the proof. So yeah, so basically what I think is basically that you have to remake the protocol such that you do, let me just show you. You pick, so now you add a value delta to the game, such that, I mean, you basically you make an API for basically computing the proof. There's no proof, and then it's returned to the user, and then you do this no proof on x+delta instead of x, where x is what we actually want to keep secret, and then we send TS, which is the no proof on x+delta and delta to the other party.
Yeah, it feels right.
And then the other party must verify. Is it? Here, y is the value he wants to prove that he knows the discrete log of. Yeah. So y is also sent.
Yeah.
So that's what will be.
In
sorry, it shouldn't be minus delta. It should be c minus minus delta.
So delta is provided by JavaScript side.
Yeah, that's provided by the user, but not to the API. The API doesn't learn delta. That's how we avoid it. So this basically means that the API only learns the padded value of the secret, and then the user can basically send the pad to the padding that is delta to the server, and the server can remove that.
Okay. I feel that I'm not sure if exactly we're talking on the same page.
Okay.
Let's say let's say we have the memory space of JavaScript, okay, and a memory space of user agent, right?
Yeah.
So can you annotate which variable is on JavaScript side, which variable is on user agent side? Of course, we have what do we use to represent privacy key? S key on the in the UA, which is the subject being proved. Okay, so this is known for sure, and we also know that everything the verifier generated and passed to the prover is in JS. Make sense to you now?
Hold on, let me just here. Yeah.
Yeah, nice. And S refers to secret key, right?
No, S is the challenge value. The secret key is X. Sorry.
No, so we have done it reverse. The secret key should never be in JavaScript, because this is what this API was set out to protect. So,
but the secret key must be in the user agent, right?
The secret key must be in the user agent. So user agent safe, JavaScript not safe.
Yeah, that's correct. Yeah, because basically what comes in
here, you have the secret key X in the user agent, and you have the X plus delta in JavaScript.
Yeah. Yes.
I see. Now it makes sense. Now it makes sense, but my brain is basically frozen now. So can you write it down?
Sorry. Yes, I'll write it down.
So I can wake up tomorrow morning and read it again. And if it's correct, we just need to give this API a name and then put it together with other things.
Yeah.
Yes. Okay. So
why don't I?
Yeah,
I'll write it down. Why don't I just write it down on the page where we have on the GitHub page where we have the description of the protocol.
Oh yes. You know that you can modify this, right?
Yes, I already did. Yeah.
Okay. Please do that. And when you have done that protocol thing, we look at the methods, and we want to design a method that is similar to the encrypt, decrypt, sign, verify in terms of style, in terms of what is typically passed in as parameter stuff. And for that to work, you actually need to actually sign some stuff with this set of API. Which should be easy because the example set signing code is already provided somewhere. So I just need to give you a few links of this so that you can run it in your browser too. then when we make new API, we are going to be similar in terms of style.
Okay.
Yeah, so yeah, that's two things. One is to write down this what is in JS side, what is in UA side, and the other is to write down the API we are going to add into this crypto interface, which we are going to inject into the crypto interface. Yeah. Okay. So James and just James Brown and Boone. I feel that we should add our API key here in this API. But how do you think?
What's that question?
Like, would you be happy to add to inject our API for rich key functions? More functions that to use the private key, they're not approved key. We should inject the code into this API, which is subtle crypto.
Are you proposing this as a namespace of Web3 or just as a root namespace, like it's like in the document?
So you prefer to have the zero-knowledge key stuff in the Web3 namespace, not under Windows.
Well, thing is, I'm thinking of about adoption. Like it doesn't really bother me which one we have. I mean, the way that you suggest is certainly more correct, but which one is best for adoption?
But even if you add it into, we add it to both, by the way. Even if you add to Web3, you still need to make the sign different, though, because the previous sign message in Web3 doesn't support you pass algorithm, so you cannot sign.
Of course, yes. But yeah, that's right. Yes, you need to add all of the parameters. Yeah.
So you need to add this too, and you probably need to add Diffie-Hellman key generation too, because that's actually useful. So,
definitely, yeah.
So if you want to add, you actually have to take most of this, and we probably need encryption. Actually, it's actually pretty easy to imagine a scenario where we can have TokenScript where the encrypt function is called. Then if we put it under Web3 space, we're gonna take all this there, actually.
Gonna take what, sorry?
All of them.
Yes, that's right, yes.
Decrypt, sign, verify, digest.
Yes. Agree, yes.
And
because
these are already exist in the browser as the method the user agent to provide.
Yes, but do we want our Ethereum key to interact with those other methods? I mean,
these methods are defined as the way for the user agent to allow JavaScript to use the key that is held by the user agent.
Yeah. I understand this is the correct way of doing.
Which sounds like a key that is held by the user agent. So it sounds like it's the same thing.
Right.
Yeah. Okay. So we can add it there. What do you think, Boone?
Is it correct? Is it right to add it to window.crypto.sato?
So first, this is spec'd out somewhere, and it doesn't have zero-knowledge proof. So we are adding new things that is not in the spec. But on the other hand, sign function currently allows signing with ECDSA curve and with all kind of hashing algorithms. It is the decision of the browsers, which are Safari, Firefox, Chrome, and IE, the 4 browsers. It's their decision to not to include SECP256K1 in an attempt to prevent blockchain being used on the web. But because we are making our browsers, we might be able to just allow that to happen. But the standard didn't forbid, ECMA script didn't forbid this the SECP256K1 key. It's all of the browsers decided for the same thing, to abandon this key, because maybe they all had pressure from the national security.
Okay, then do we need to consider name clashes? if
we
they
don't
do
actually,
add something
we
like
don't
that.
actually hash name because this signing function here, it is the same signing function if you use the SECP 256 R1 or 512 R1 or any of the curves. Because this signing key allows you to specify what kind of key object to use, which allows different curves. And I think they accept 12 curves, but they intentionally removed the one that is used by Bitcoin. So
Okay.
if we do this, there will be no name clash because we simply allowed one more key to be passed as a key object. Does it answer your question?
No. Are you talking about adding a function or modifying a function?
Modifying the function. I'm talking about modifying encrypt, decrypt, sign, verify, these 4 functions, and actually derive key function, these 5 functions, to allow a key on the SECP 256 key 1 curve to be used.
Oh, I see. Okay.
The function definition will not be modified. The namespace will not be modified. The parameters will not be modified. It's only what's in the parameter that is modified.
Oh,
for example,
then yes, it sounds like we should put it there. Yes.
But this is only on the part of exposing encrypt, decrypt, sign, and generate key, a derived key functionality. But if we expose the zero knowledge proof functionality, we actually are going to add one more functions.
Yes, the adding, when we add function, that's when we need to think if there will be name clashes.
Yes, but to make all existing functions compatible with SECP 256 K1 would make us able to generate JavaScript code that can work with OpenSS library that is on the other side of on the server side. Otherwise, everything on the server side has to install blockchain-specific libraries, which is a burden for the future popularity. Say, if you imagine, if you have a PHP built website, and then you have to install a new module in order to support KCAC. And that module is not OpenSSL, which means you have to double audit the library you are using, because OpenSSL specifically said that they will not support KCAC. And then we are caught in the middle between the solution world and the crypto world.
Yes, I agree. We should add them. But my question is where it's actually it was your question. Where do we add them to? Which namespace does it go to?
Yes, so and that question is on the key functionalities like encrypt, decrypt, and as well as the key as well as the new zero knowledge proof API.
Yes.
And the other thing that I'm against adding that into Web3 is that this set of API is just not just the name of functions. It also contains objects. For example, how do you define an ECDSA parameter, which is a curve? And how do you define, let's say, SHA 266 versus SHA 501.12? So if we want to expose all these functions, we not only need to copy these functions into Web3 dot something, but we also need to copy the object space. Of course, we can always make short link, which is Web3.crypto is actually a link to this interface.
Yes, or I suggest the alternative, which is to create a new namespace.
Yeah.
TokenScript dot something, for example, and move everything there.
And then once we have a new namespace, are we going to copy this design?
Are we going to do what?
Copy this design, like that name that there are encrypt, decrypt, sign, verify, digest, generate key.
No, we just leave this there.
We just need to what?
We just leave them there.
So we copy
You
the
keep them in. The new things go under TokenScript. Whatever is already in window.crypto, we just leave it there.
Okay, so you suggest that we do implement subtle crypto dot window crypto dot sign that accepts the Bitcoin curve. However,
Yes.
zero knowledge proof one, which is a new function, is in a different namespace.
Yes.
Okay, that makes total sense to me. Yeah.
If you want to add the, I forgot the function name, maybe sign, which is already in window.crypto.subtle. If you want to add functions that proxy over to those, so that the developers don't ever have to call crypto.subtle, I think that's okay too. But it seems like a good chance for us to create a new namespace instead of putting things into Web3. Even Web3, the Web3 namespace might be moving away.
So in a
because
sense,
there's now an Ethereum namespace.
Damn it, again. If we have a new namespace, I feel TokenScript dot something namespace should be the namespace provided to web developers, not to the token issuers.
Okay.
Yeah, so you have TokenScript, or I would actually call token. Token dot, let's say this token dot event date, which would return, if it's a ticket, the event date. However, if you can also call token dot prove, which would prove this token to a website, for example. However, the web developers who calls these functions, token dot something functions, will actually not touch the crypto, because it's just a simple bad thing that we want website developers who want to make their website compatible with a certain token to actually call the sign function.
Okay.
Do you think why? Do you understand why I think so? I mean, you just need to empathize with it, but no, you don't have to agree. Like, because I want to encapsulate this so that token functions are directly related to cards and not to how cards work. And the cards might actually call crypto.sign.
Yes, but what if we do something like TokenScript.token as well as TokenScript.crypto?
That I want Web2 developers to not know the existence of terminologies like block ID, contract name, stuff. And the fact that you are putting TokenScript.token and TokenScript.crypto means that there's another set of API not hidden from web developers.
Oh, okay.
Yeah.
Sure. Then we just have to come up with a reasonable name.
This is just what I explained what I want. I didn't decide for it because otherwise, why do we need a meeting? So you might.
I think the other factor that we need to think about as well is protecting a user from inadvertently signing something. So, like, let's say a user of the wallet goes to some site that is asking for the crypto interface that is standard, and then
totally agree.
Okay.
This is exactly why I propose that the interface for the web developer should be different than the interface for the crypto. And although we are thinking about how to make the crypto interface, we are actually thinking it for now as a simple way to provide zero knowledge proof, but for the future as something that we can use in TokenScript.
Yeah.
So there are one layer of protection in the subtle crypto, the window.crypto object. That is, there's no way that JavaScript can learn the key. That's the layer of protection that is in window.crypto. But when we produce TokenScript, interface, there are a second layer of protection, not only protecting the website from learning the private key, but also preventing the website from signing random stuff, because the signing random stuff code has to be signed by issuer, not
Yes.
by the website.
Yeah.
So there are two layers. So we're adding one layer. They already have one layer of protection on the key, but we have another layer of protection on the message. That's why the interface exposed to the web developer is different than interface for crypto stuff. That I think. Something happened?
When you say they are separate, are you saying that let's say we do call them, let's say we call them TokenScript token, just one word, and TokenScript crypto. Are you saying that only one set of this is available at a time? So it's impossible to access the other? Because if the function is there, is available, then of course they will be able to call it, no matter what we call them, no matter how we name them. It's not going to protect the developers just by giving it a different name.
So yeah, so I kind of want not to inspire the web developer know that there's a crypto interface. So that's why.
Oh, okay.
Okay. So
sure. That's a valid reason. I'm just trying to understand whether you are hiding you're removing the functions totally or just hiding them.
Yeah.
Okay.
So we might actually want to remove it from the access from the website at all, but there has to be a bridging period. Because if the website can access it, somebody can compromise the website and ask users to sign stupid stuff. Like transfer.
But they could ask, but they can ask the user to sign, but the user will get a prompt. Isn't that protected by the user agent?
Yes, it is. The user will always get a prompt, even using today's window.crypt. If anything has to be signed, it's not silently signed. But we want to, you remember early days, that if the website has a SSL certificate that is not trusted, the browser will give a warning and allows user to continue using it. And eventually they don't allow it to be used at all.
Okay.
That is about 10 years time, I think. So yeah, it's quite far away, but eventually I hope that not only the signing is a message to the user, but also that the signing has to be done by signed code.
Okay.
Otherwise, you have to turn on the debug mode of the browser to sign that.
Okay.
Yeah, but we cannot get there now. Yeah. Okay. Yeah. Sorry, I abused your time because it's much longer than previously I thought. Yeah. Okay. So I guess that's it.
Okay.
Yeah.
Okay. Cheers.
Great. Thanks.
Cheers. Thank you for everybody.
Yes.
Yeah. Thank you everybody.
Cheers. Thanks. Okay.
Bye.